In this section, we will see about thread synchronization. Thread synchronization helps us to resolve shared data access related issues. We will see how thread synchronization is implemented and what are the various constructs used for thread synchronization. This is the list of all the questions you can expect on thread synchronization. How do we avoid shared data issues? What is monitor or intrinsic lock? What happens when we call wait inside synchronous block? What is difference between sleep and wait? Difference between notify and notify all? How can we synchronize collections? Let's see these questions and the theory behind thread synchronization in the subsequent slides. How do we avoid shared data issues? In Java, we have synchronized keyword as well as locks, which can be used for synchronization. The synchronized keyword can be used with methods or it can be used to create synchronized blocks. The synchronized keyword can be applied to a variable. So, how it works is that it acquires lock on that object before entering the synchronized code, and after exiting from the synchronized code, the lock on that object is released. This is how synchronization works in a synchronized block. If synchronized keyword is applied to a static variable or method, then the lock is obtained at a class level and no other static call can be made from any of the threads. So this is how synchronization works. What is monitor or intrinsic lock? In the last question, we saw how synchronization works. Synchronization creates intrinsic or monitor lock on objects. Every object has this monitor lock and can be monitored from within a synchronized code. This monitor or intrinsic lock is reentrant. That is, the same thread can get access to different methods of the same object which is on which synchronized block is used, and it does not have to reacquire the lock. It can reuse the lock which it had obtained during the first method call. Say for example, it calls method A and method A calls method B, then it does not have to acquire lock again for method B. It can reuse the lock which it had acquired for method A. This is what we mean by reentrant. What happens when we call wait inside synchronous block? In previous slides, we have seen how synchronization has been implemented in Java using monitor logs. So monitor logs helps us to protect a critical code. If a method is made synchronous or if a code is put inside a synchronous block, then that code can be executed by only one thread at a time. But there might be some scenarios where we want that thread to pause its execution and give control to other threads for execution. Say, for example, if there are two threads, thread 1 and thread 2, thread 1 cannot perform any action until thread 2 has executed some important task. Then thread 1 should be put to wait state and should be brought again back to runnable state only when thread 2 has finished all the important tasks. To achieve this, we use the wait and notify method. The wait and notify method are available in each object and they are part of the intrinsic or monitor locking mechanism. So, whenever a thread enters a synchronous block, it gets associated with a monitor. And when an object's wait method is called, the thread in the monitor goes to a wait state and gives its control to other threads. The lock or the monitor lock over that object is also given over to other threads for execution. Thus, we can achieve the scenario which we just discussed before. There's another thing which we need to take care of while implementing a wait notify mechanism. There is a phenomenon called spurious wake-up. Spurious wake-ups are false signaling due to some OS implementations. Due to this false signaling, a thread may get into runnable state from wait state. To avoid such scenarios, we should put a wait method inside a while loop and it should constantly check for that condition. And if that condition is not met, then the thread should be again put into wait status. This way, we can avoid issues due to spurious wake-ups. What is difference between sleep and wait? In a sleep state, thread cannot resume work until the sleep interval is completed, whereas in a wait state, thread will resume execution as soon as it receives notify or notify all signal from other threads. This is the only difference between thread sleep state and wait state. Difference between notify and notify all method. We have seen how wait, notify and notify all methods are used for monitor locking purposes. Notify and notify all are used to signal threads in waiting state to get back to runnable state and start executing. Notify will signal only the next thread in line for execution to resume execution, whereas notify all will signal all threads which are in waiting status to resume. But in notify all, only the thread with the highest priority or the one chosen by the OS scheduler will be resumed, and all other threads will go to block state as they cannot get the monitor lock for execution. We should use notify all when there are multiple threads waiting for a certain condition or event. How can we synchronize collections? Most of the collections like hash map, lists, and sets are not synchronized and hence cannot be used in a multi-threaded code. We have concurrent collections which we will discuss about later, which can be directly used in a multi-threaded code. But what if we want to use the same collections like hash map, array list, and linked list in a multi-threaded environment? In such scenarios, the collections framework provides us with a mechanism to synchronize the objects of these classes. Using collections.synchronize sorted map or synchronize set, synchronize sorted set, or synchronize list, or a generic method called synchronize collection, we can synchronize all the method calls of these classes. So these methods are static methods available in the collections class. Thus, we can use the same collection classes in our multi-threaded code, but their performance will not be good as all the methods will be synchronized and will block each other's execution.